Yo, you won't believe this idea. gotta talk. Sometimes to know what to do and how to do it properly, we first need to get a good understanding of the pitfalls and caveats of a particular technique. It seems there is not much to know and no need to take great caution when it comes to such a straightforward subject as unit testing, but nothing more misleading. If we do not follow specific standards and principles, we might quickly get ourselves into trouble and do more bad than good for the quality of our application. Now, dive in with me and let's go through the wall of shame of unit testing. Test coverage percentage has always been a conflict point between the team members. Some saying it should be between 60 and 80%, while others say that the goal should always be 100%. In my opinion, the answer is, it depends. Imagine that you're driving behind a car and you want to overtake it. Now, with what speed you should perform the maneuver? The answer is well known. It depends. It depends on the speed the car is driving, on the traffic around you, on the type of vehicle you are trying to overtake. Maybe it is a police car or your boss in front of you, and overtaking might not be the best idea after all. There's no way I'm driving behind you on a motorway. But you don't even have a driving license. Besides, I'm not your boss. So why am I doing all this stuff? Because you love to do it and you want to do it. I never told you how to design all this stuff. Bro, this got emotional. Anyway, the same idea applies to covering code with unit testing. Common sense defines the percentage of the coverage that you should aim for. There are some rules of thumb that you can and should follow, and the coverage percentage will uncover itself for your particular application. For example, critical pieces of code or components ought to be tested first with all the logical paths covered. Auxiliary and less error-prone code ought to be tested afterwards, also with all the logical paths covered. If the deadline is closing fast, we have at least the crucial units tested. Go for testing the happy path first, leave the exceptional cases for last. So unless you are promised an extra bonus for testing every written line of code, covering methods listed below would be just a waste of time. That is, trivial constructors, getters and setters, or methods that just call their collaborators. In most of the situations, the method being tested has more than one logical path. What you don't want to aim for is writing one test covering all these paths, or more than one path in general. Let me try to illustrate that with a basic example. Let's take a look at the following. This is the simplest possible method that contains tiny amount of logic but is still testable. Now, without proper testing technique, we can still mess this thing up. This test will obviously work and cover all the logical paths as intended. There are some problems though. The name of the test cannot be anything more than just the name of the tested method. When the test fails, we look at the report and we are not able to verify what exactly went wrong. We just know that there was some error while testing this particular method. If this is a common pattern in our system, then a ton of time is wasted for resolving unit testing issues. This should not take place. Also, it is harder to analyze and maintain. There is a high chance that the method under test will be changed or extended at some point. That would probably cause more logical paths to be present and the need to add more variations to the test, which would clutter it up even more. So to conclude, the single responsibility principle should be applied to all the code we write, the test code included. Otherwise, we would have a real irony in construction. Can't you just say what you have in mind? Don't listen to him. The point is, you'll be creating tests to reduce the technical debt, but at the same time introducing technical debt in your test codebase. And that leads to every automation artist's worst nightmare, ignoring all the tests altogether. We need to talk again. Too many or too long private methods are generally a sign of a lousy class design. You probably ended up with a bunch of public methods doing more than they should, have more than one single purpose. It will be hard to unit test them in a maintainable and readable way. If you follow the single responsibility principle though, your classes will usually have 1 to 3 specialized public methods. I would say not larger than 15 to 25 lines of code, accompanied by 1 or 2 private methods each. Thanks to that, even though the public method uses some private implementation encapsulators, the method itself is not complex enough to perform the test cases on itself only. No private method testing is ever needed in that scenario. Some of the traits of private methods that make them a really bad target for unit tests can be the following. Private methods are implementation detail, and testing them forces our tests to focus on particular implementation instead of the behavior. Other classes, clients, only see and care about public methods, and they are the ones that define the behavior. And again, behavior is what we are aiming for in the testing suite. Another thing is they are highly prone to change and also require the use of reflection, which makes the analysis way harder. It also makes them harder to maintain, as you need to get the method with a raw string. If the method name changes, we have a problem. Once the production method has been covered with tests, the final step is to perform the refactoring. Because we have written all the tests and the production method is guarded against any changes which would cause that test suite to fail, we can basically do any refactoring modifications to the design we can imagine. If we go too far though, the suite will fail and remind us we have changed the logic. So let's assume we have a method given below and we have written all the possible tests. When we take a first look at it, we are not quite sure how to feel about it. There are some exceptions at the beginning and this big something later on that is working with strings and numbers and conditionals and you get the picture. Everything according to the test suite works, but at this point it would be a deadly sin if we left this production method as it is. We need at least a couple of minutes to understand this code. We have the capacity though to improve that to almost an instant. We have every logical path covered with tests and it literally begs for some improvement. Let us never leave an opportunity like this behind. We have refactored a bit our original method by moving a lot of the code into specialized private methods. Now, thanks to refactoring, the public method is a lot more clear and has better maintainability. We have extracted some of the constants, encapsulated some of the code within self-explanatory private methods, and also we have removed duplication into a common generic method. Running these previously written tests will ensure us that the logic has not changed and all the tests within the suite still pass. Imagine a situation where you start to climb the highest hill in the area, and after all the effort, when you reach the peak, you immediately start to descend. Now, why would you want to do that? Stay a bit on the top, take the pride in what you accomplish, and enjoy the amazing view. You have earned it greatly. So, covering the code with tests is the most important thing, but along with refactoring, we end up with a tandem which just immensely boosts the quality of the code. Do not miss out. So far, we have covered private methods, searching for the right path, refactoring. Now, what about when we need to call non-trivial methods or collaborators of our system under test? We are talking about non-trivial collaborators which reach for external resources, third-party web services, system files, or for example invoke complicated internal structures and features like threads. Testing these, even though very tempting and justified at certain level, is not relevant in the unit testing context. Not even wanted to be exact. A unit test should test exactly and only what the name implies, which is a unit. Accessing methods of the collaborators which are not trivial is certainly against that foundation. Apart from that, the main strength of a unit test is speed. They are fast and they should stay that way. Now, trying to call any of the resources from the aforementioned list would slow our tests significantly. We don't want that. We want a slick and fast unit testing suite for applications so that it can be run in seconds by any developer at any given time during the entire development process. Okay, so how can we exclude those invocations? We are calling real objects in our tests, right? There is an answer to that as well, and it's called mocking. But no one likes to be mocked. Our unit under test has no choice. Poor unit. Don't worry, mate, no harm to them is actually done. In fact, they benefit from that a lot. I hope, otherwise you would need to deal with me. Oh my, I'm so scared. That's it, you're getting what you deserve. Oh, you want some of me, boy? Hold on. Hold the horses. I'm not done yet. Now, we have seen how we should not approach our unit tests. We now know that accessing a database or a file do not have a place here. Now, we realize also that skipped refactoring is simply being lazy in the end and not finishing the job. We understand also that private methods are implementation details and should not be tested on their own, under any circumstances. We'll also never try to test all the possible logical paths under one method. Now, having all that in our mind, right now let us fire up our IDE and write some damn good unit tests. I hope you enjoyed today's episode, and I hope it has added a few ideas to your software craftsmanship toolkit. If you wish to expand further your knowledge of combining software craftsmanship techniques with automated testing, then please check out my website to gain more understanding in that area. Also, do not forget to like the video and hit the subscribe button if you found the content to be of value. And remember, Programming is supposed to be a creative, fun, and fulfilling experience. All of you software artists out there, I'm looking forward to seeing you again on our next episode.